Hello everyone, how are you? I am fine and I am going to show you the autoregressive distributed lag model long run and short run coefficients using Eviews 12. If you are new to my channel, subscribe to my channel to get updates. Let us proceed to the autoregressive distributed lag models long run and short run coefficient determination in Eviews 12. The short run determination of autoregressive distributed lag in Eviews 12 is different from the short run determination in previous version of Eviews. So, before proceeding to the short run coefficient determination of autoregressive distributed lag model in Eviews 12, let us see the model selection summary. The model selection summary item on the view menu allows you to view either criteria graph or criteria table. The graph shows the model selection value for 20 best model used in your regression. If you use either AIC, BIC or HQ criterion, the graph will show the 20 models with the lowest criterion value. Not only this one, again, if you choose the adjusted R squared as the model selection criteria, the graph will show the 20 models with highest adjusted R squared. The table form of the view shows the log likelihood value, the AIC, the BIC and HQ values, and the adjusted R squared of the top 20 models in tabular form. Now let us see how to identify a short run coefficient in autoregressive distributed lag approach in Eviews 12. The view or coefficient diagnostics menu offer the new item long run form and bound test in Eviews 12 and Eviews 11. The view or coefficient diagnostics menu in Eviews 9 separately shows you the bound test as well as long run and short run coefficient. But here in Eviews 12, the long run form and bound test is shown in a single views or in one command. Every autoregressive distributed lag model is associated with conditional error correction model. This view displays a table of least squares estimates corresponding to this conditional error correction regression. Here you have to note that the lag of the dependent variable in this regression will always be suffixed by a single asterisk, while some variables will be suffixed by double asterisk. Moreover, any variables suffixed by a double asterisk indicates a dynamic regressor with an optimal lag of 0. As such, Eviews does not include lag and difference of the such variable, but estimates them contemporaneously. Accordingly, such variable should be reinterpreted in the context of the decomposition so that they can be included in the term which arises in each of the conditional error correction regressions. In particular, least scarce estimates of coefficients associated with such variable are simultaneously estimates of the coefficients associated with as well as. When this is the case, Eviews 12 augments the table of regression estimates with a note that such variable should be interpreted as z is equals to z into log 1 plus difference of the z. Thus, z equal to z into minus 1. Let us proceed to the Eviews 12 autoregressive distributed lag approach or lag models in practice, and let us open the Eviews 12. This Eviews 12 is student version. Under this version you can copy your results and paste as you want, but you can copy and paste the picture only. So I have a data here which is named as result tags w1, and let us open this data and let us going to estimate the autoregressive distributed lag approach. So here is a variables, independent variables, but I am going to select a few variables among these variables. So let us select them. Let us select a tax, then governmental effectiveness, regulatory quality, then political stability, government effectiveness and corruption, and click on the selected variable and open this as equation. So your selected variable is depicted here, and our tax is dependent variables and the other remaining variables independent variables, and let us select the estimation method. So click on this and scroll down your cursor and select the autoregressive distributed lag models. So here the other thing is lag selection. Since our sample is 25 years, we are going to limit our lag to the 1. So for both dependent and independent variable regressors, I am going to select the maximum lag of 1. And here there is another way, that is leads you the lag selection. I'm going to click on the option and select a model selection criterion, maybe like a confirmation. So storage criteria and anchoring criteria and adjust risk for our case are going to select storage criteria. So our result is depicted here. Our result is depicted here. You can see here the result. So our dependent variable is tax. Our method of estimation is autoregressive distributed lag approach. Our sample period adjusted is from 1997 to 2020. Observation is 24 because there is a lag, and maximum dependent lag is 1. It is based on the automatic selection. Model selection method, storage criteria, which I am shown before. Dynamic regressors, one lag automatic. The first one is one lag is dependent variable. Then the other is even you have select the maximum lag as 1, the system generated a automatic selection. Then we are a fixed regressor, which is represented as the C, number of models evaluated, it is 64. Then selection model autoregressive distributed lag 11000001. So here let us see the outcome. So here we have a coefficient. In this section you are not allowed to discuss these coefficients because this coefficient is nothing to show the effects of the variable on the other variables. But here you are only use this regression to see the adjusted R-squared log likelihood, F statistics and probability, as well as the minimum dependent variable you will get here, and all of the model selection criteria, Akakin, surgery, Hanan, Queen, and Rabin-Watson stats for autocorrelation. And there is also another technique that is used to test the autocorrelation rather than Darwin-Watson. And now let us see the long run and short run coefficient, including bound test in Eviews 12. To see this, we are going to click on the views, then coefficient diagnostics. So in this Eviews 12, you can get the long run and bound test together rather than in a separate way. So click on the long run and bound tests. Then here is the long run, the short run coefficient, and the bound test. So this is a short run coefficient. This is a short run coefficient. Short run coefficient is here. This is a short run coefficient which is stated as a conditional error correction regression. From previous version, the short run coefficient is depicted as d of the variable or difference of the variables, but here the issue is different from that. Only you are directly take the short run coefficient for these two variables only. The remaining variables coefficient, short run coefficient determination is different from this. So as you have seen in our previous section, the short run for rule of law is determined as let us see this. let us see this one. Let us see this one. The short run coefficient of this variable is determined as z, or interpreted as z equal z into minus 1 plus d into z. This is the short run coefficient. The short run coefficient. Again, here is similar. The Rg quality is also determined through using this asterisk value. Again, the political stability short run coefficient is also determined through using these asterisk values. Again, governmental effectiveness, again, it is determined through using this technique or method. And when you come to the long run, there is no phrase that says a long run coefficient. It says level equation. Level equation. The level equation which shows a long run coefficient. A long run coefficient, there is a restricted constant and no trend, so our result is here, is a long run coefficient for all variables. This is error correction and long run coefficients or equation, which is tax, then regulatory quality, then the rule of law is depicted, voice and accountability extra. So this is how our coefficient is determined. Let us come to the bound test. The bound test, here we have a bound test. The main advantages of the Eviews 12 is that it shows the existence of the short run and long run relationship, but at the same time, with the similar data, Eview 9 shows that there is no long run short run relationship. The Eview 9 bound test shows you there is no short run long run relationship with a similar data. Similar independent variable and dependent variable, while the Eview 12 shows the existence of the co-integration. Eview 9 is not shown the existence of the co-integration. This is the advantage of the Eviews 12. This is sort of the coefficient determination in Eviews 12 in autoregressive distributed like model, and there is also another coefficient diagnostic test, for instance, the variance inflation factor. The variance inflation factor. Here we are troubled with, we are confused with the uncentered and centered variance inflating factors, but various scholars advise to use centered variance inflating factors because these centered variance inflation factors shows a lowest values rather than using uncentered variance inflation factor. So I also advise you centered variance inflation factor when checking a multicollinearity problem. The other issue is the residual diagnostics. For instance, you can check the existence of the autocorrelation in another way. This is Q statistics probability. Test the autocorrelation. For instance, the Q statistics probability shows that whether the autocorrelation exists or not. If the probability of Q statistics is greater than 5%, there is no autocorrelation. Again, the other issue is normality test. Here is a normality test. When you use this normality test, follow the Jar-Kubera. When the probability of the Jar-Kubera is greater than 5% or greater than alpha, the data is normal. Again, the other issue is serial correlation. Let us set to lag 1, set lags to include 1. And here it shows there is no serial correlation in your variables in our model. Again, the other issue is heterostaticity test. Here are tests Brosich, Pagan, Godfrey, and ARC test. The ARC test shows again there is no heteroscedasticity and homoscedasticity existed in our variable. This is all about the short run and long run coefficient and model diagnostic test in Eviews 12. Thank you for watching.